Good day, ladies and gentlemen. Here is our review for Quiz 7. Once again, I will prepare a video for you, which will be on YouTube, and the notes, the very notes that I'm going to be writing on here today, I will post on Blackboard under your Module 2. So please take advantage of the quiz review. The quiz will be posted Monday at 7 in the morning. And will be due Tuesday at midnight. All right, here we go. First question. Consider the following rational expression. Now, one thing you should know about this word rational, which may seem a little bit ethereal, is that it's really very commonplace. It can be a good synonym for rational is going to be fractional. So if we're talking a rational expression, we're talking a fraction. It's that simple. First thing it asks me to do is to reduce to lowest terms. What that means I do is, number one, I factor numerator and denominator. Just like I would a normal fraction. So the numerator obviously doesn't change, but I do see a common factor of x in the denominator, so I factor it out. I get x minus 5. So reduce to lowest terms. Hey, look here, I have a common factor, top and bottom. Anything over itself simplifies to 1. What we say is they cancel, and I get 1 over x minus 5. So that is the reduced to lowest terms expression. Okay, so I factor the numerator and denominator. Secondly, I cancel common factors. Just like a normal fraction. All right, second thing is I'm being asked for restricted values for x for the given expression. Now you remember that I cannot allow any value of x to be in my domain, my considered values. I can't allow any value of x that causes a denominator to be 0. If you have something like 7 over 0 and put that in your calculator, it's going to say, I got no idea what you're talking about. So I need to avoid any value of x that makes my denominator 0. How are we going to find out what that is? Well, first thing we're going to do is factor the denominator. Hey, we already did that, right? So we factor the denominator. It turns out to be x times x minus 5. Second thing we're going to do is realize that either one of these could make the denominator 0. If either one of these is 0, the denominator will be 0. The way I'm going to express that thought is I'm going to set each factor equal to 0 and solve. To find out what x cannot be. So the first one is just plain old x. That was easy. The second one is not going to be difficult. I set it equal to 0 and solve. That means get x by itself. So find the restricted values. There they are. X can't be 0. X can't be 5. Hey, take it back to your original expression. If x is 0, that's 0. If x is 0, that's 0. 0 minus 0, that gives the whole thing a 0. How about if x is 5? 5 squared is 25, minus 5 times 5, which is 25. 25 minus 25, that makes it 0. So these are the two values that are restricted values. All right, number 2. One of the sections in your 3 sections that are covered is combining functions. That is talking about the sum, difference, product and quotient functions. These are new functions by combining two regular old ordinary functions. Their sum, their difference, their product, and their quotient. And these guys are not difficult at all because of the definition of the sum function. F plus g of negative 2, f plus g of 7, f plus g of anything is going to be f of that thing plus g of that thing. That's all it means. So f plus g of negative 2 means f of negative 2 plus g of negative 2. Hey, well, what do you know? I've already got f of negative 2. It's right here. F of negative 2 is 4. And I've already got g of negative 2. G of negative 2 is negative 13. Well, that's easy enough. 4 plus negative 13, negative 9. Got it. Once I know the definition, it kind of simplifies nicely. F minus g of negative 2 simply means f of negative 2 minus g of negative 2. Again, I already know f of negative 2, it's 4, minus this time g of negative 2, which is negative 13. That's going to be 4 plus 13. No problem. How about f times g of negative 2? What in the world does that mean? Not surprised. It simply means f of negative 2 times g of negative 2. That's the product function. F of negative 2 is 4 times g of negative 2, which is negative 13. 4 13s is 52. Got a positive times a negative, negative 52. This is not hard. F over g of negative 2, or the quotient function, simply means f of negative 2 over g of negative 2. That's 4 over negative 13. We could more conventionally express that as negative 4 13ths. And go ahead and list it as a fraction. Since it doesn't say simplify to 2 decimal places, go ahead and list it as the exact fraction. Don't put in an approximation or it won't give you the correct answer. Hey, those are the combinations of functions: sum, difference, product, and quotient. Not too difficult. There is, however, a fifth combination of functions, and it is not adding, subtracting, multiplying, or dividing. It's something other. It's called what's it called? F of g of x is the, I can't think of what it's called. Sorry about this. Oh, it's not coming to me. Composition of functions. Thank you very much. Composition of functions. F composed with g. The composition of functions is expressed with this new little symbol. It's a new operation, so we need a new symbol. And the composition of functions simply says this: if I have f of g of 4, what that means is the first function, whatever it is, evaluated at the second function evaluated at 4. So f of g of 4 simply means the first function, f, evaluated at g of 4. So I got an order of things to do here. First of all, I got to figure out what g of 4 is, and since I have g of x, I can find that. I got to find out what g of 4 is. Once I find that, then I evaluate the function f at that particular value. So here we go. Composition of functions. First of all, in parentheses, g of 4. G of 4 says, here's my g function. G of 4 says everywhere I have an x, I'm going to put a 4. So it means the square root of, instead of 4 times x, it's 4 times 4 over 9. There's g of 4. So again, it's f of the square root of 16/9. Square root of 16/9 is the square root of 16 over the square root of 9. It's just 4/3. Okay? So f of g of 4 means the first function f evaluated at g of 4. Got to find g of 4. Here's g. G of 4 means everywhere there's an x, I'm going to put a 4. Did that. That's square root of 16/9. That's 4/3. I'm not finished because I still have to find f of 4/3. Here's my function f. It says everywhere I have an x, a value, I'm going to put that plus 5 and take the square root of it. So f of 4/3 means, here's my f function, the square root of 4/3 plus 5. Now notice this is not going to come out even. That's why we have this round to 2 decimal places here. This thing is not going to come out even. You can approach this in lots of different ways. You can find this, add that, and then take the square root. Or you can, if you wanted to, make it very simple. In terms of thirds, 5 is the same as 15/3. So 4/3 plus 15/3 is the square root of 19/3. This is obviously going to be some calculator work. So let's see what we got going here. My square root function is a second, so I have to do that. Here's my square root, and you're going to have to figure out your own calculator. Square root of 19/3, 19 divide 3. Let's see what that gives me. 2.5166. 114, etc. But I want to round to 2 decimal places, which means I go to the 1 to 3rd decimal place to see if I round this number up or leave it alone. Hey, it's 5 or bigger, so I'll round this up, which means this is approximately equal to 2.52. And that's what I would enter rounded to 2 decimal places. Again, this is the composition of functions. Don't want to forget that again. All right, number 3. Number 4. Identify the correct graph and the x and y intercepts for the following polynomial function. Now, one thing they're going to give you is 1, 2, 3, 4 options. This function is represented by one of these guys, and I got to figure out which one it is. And it's going to be determined by a process of elimination, and here's how we're going to do it. We're going to first of all find the x and the y intercepts for this particular guy. All right, let's do the x intercept first. And it could be more than one, and in fact, it is going to be more than one. And here's how we're going to find the x intercepts. Number 1, substitute y for s of x. Now, you guys know that s of x equals something is the same as y equals, right? We've done that enough times before to have this down. So let's go ahead and in the place of s of x, y equals okay. Now how do you find an x-intercept? To find an x-intercept, you let y equal 0 and solve for x. Every time you want to find x-intercept or intercepts, you let y equal 0 and solve for x. So in the place of y, we're going to put 0. Here's where we're going to use that property of 0 that has a bunch of things multiplied that give me 0. If I have a bunch of things multiplied that give me 0, the possibility is any one of these could equal 0. So what I'm going to do is, my next step, the way I'm going to express it is, set each factor. These are the three factors. Set each factor equal to 0 and solve. Well, that shouldn't be too hard. Here's the first one. Second one. And the third one. Got to solve these guys for x. So I'm going to add 4. That's easy. X is 4. I'm going to subtract 5. No problem. X is negative 5. And I'm going to move this x to the other side. Add x to both sides. It says 1 equal x, but that's the same as x equal 1. So here are my 3 x-intercepts. In other words, when I look at the graph of this polynomial function, it is going to cut the x-axis in 1, 2, 3 places. At negative 5, at positive 1, and at positive 4. All right, I've just found my x-intercepts. Now this is going to be some kind of strange curve, which means if it's going to cut in these 3 places, it's either got to do one of these guys. It's got to come down, up, and back down, or it's going to go up, down, and back up. It's going to be one of those 2 things. But it's going to intersect the x-axis in these 3 places. Hey, you know what will help me find out what this thing looks like? That is to find the next thing I'm looking for, the y-intercept. And there's only going to be one y-intercept on a function, otherwise it wouldn't be a function. So how do I find a y-intercept? Well, that's easy. Let x equal to 0 and solve. So in the place of y equals, it's very nice that they factored this for us, isn't it? So everywhere there is an x, I'm going to put a 0 and solve for y. So y is 0 minus 4, 0 plus 5, 1 minus 0. Let's see, 0 minus 4 is negative 4. 0 plus 5 is 5. 1 minus 0 is 1. Hey, anytime you want to find a y-intercept, you let x equal to 0 and solve for y. Guess what y is? Negative 4 times 5 is negative 20, times 1 is negative 20. So where this curve is going to intersect the y-axis is at the point 0, -20. It's going to cut the y-axis at -20, so way the heck down here. Somewhere. So obviously it's going to go down and back up and back down, isn't it? It can't go up and hit -20 without going through the x-axis again. So it's going to have, in general, it's going to go down, it's going to go up, it's going to go down. That's what the graph is going to look like. So I'm looking for something that has these three x-intercepts, -5, 1, and 4, and cuts the y-axis way down south here. So I'm going to look for that right now in these 4 graphs. It's going to go way down, cut it at -20. See, this is -30, so there's -20. Yep. 1 and 4. This is it right here. So notice this guy, the y-axis is not cut at -20. The y-axis, where's the y-axis? Forget that one. Y-axis is not cut at -20. So this is my answer. That's the one I will choose for my graph. Now let's see if we can figure out how to put in the x-intercepts. Let's see what it says. Express all points as ordered pairs. That's how you're going to avoid making some errors here. If I put the x-intercepts are -5, 1, and 4, it's going to count it wrong. So I'm going to have to put it at -5, 0, 1, 0, and 4, 0. And for my y-intercept, I'm going to have to put it at 0, -20. All right, has to be expressed as ordered pairs. All righty, that's number 4. Number 5, last one. Consider the following polynomial inequality. Notice, not an equal sign there. There is an inequality symbol. So I have to find the interval endpoints first of all. Now, when I have an inequality and I try to find the solution set, it's going to be parts of the number line. So I got to find the endpoints of the parts of the number line that divide my solution set. So I got a typical number line here. How am I going to find these interval endpoints? All right, first step is to factor the polynomial. Thank you, Mr. Hawks. It's already done. It's already factored. Second step, set each factor equal to 0 and solve. Just like in solving that last equation. Set each factor equal to 0, not less than or greater than, but equal to 0, and solve. All right, here's the first factor. X squared equals 0. Here's the second factor. And here's the third factor. Set them each equal to 0 and solve them. This is easy. X is 5. This is easy. X is -6. How do I do this guy? Well, take the square root of both sides. Square root of x squared is just x. Square root of 0 is 0. That wasn't hard either. So these are my interval endpoints. 0, -6, and 5. Sometimes these guys are called critical points. They're the points where the function stops going up and starts going down. It's the places on the number line that break up my solution set. So I got to mark it. -6, 0, and 5. All right? These are the sections that will be in or excluded from my solution set. So this is the foundation I'm going to be looking at and evaluating to determine which parts are in my solution set and which parts are not. So let me reproduce that, because it asks me to test each interval. And keep in mind here, I got 4 intervals. This one, this one, this one, and this one. How am I going to find out which of these intervals is in the solution set and which of them is not? I'm going to test each interval. How do I do that? Test a representative value in each interval. So I'm going to test something in these intervals. If the thing in these intervals works, the whole interval works. If the thing in the interval does not work, the whole interval does not work. So I'm going to pick something in this, and this, and this, and this. Here we go. Let's pick something in this interval right here. How about -7? That's in this interval, right? So let's test -7. How do I test it? Well, I actually put it in the expression itself. Everywhere there's an x, I'm going to put a -7. And I'm going to see if it's greater than 0. If what I get here when I put -7 in this is greater than 0, then this is a good section. So let's go. So everywhere there's an x, I'm going to put a -7. -7 plus 6. -7 minus 5. The question is that going to be greater than 0? I don't know. Let's find out. -7 squared, that's a negative number squared, is a positive 49. -7 plus 6 is -1. It's a -12. Question, is that going to be greater than 0? How many negatives do I have? 2. Even number of negatives. That means I'm going to get a positive number here. It doesn't even matter what it is. It's a positive number. It's a big old positive number. It's greater than 0. Yes. Greater than 0? Yes. A positive number is greater than 0. This is a good section. This section checks out. You see what we did? We picked one number in this section. If I get a true statement, the whole section is good. All right, let's test something else. Let's test, -3 right there. That means everywhere there's an x, I'm going to put a -3. -3 plus 6. -3 minus 5. And I'm wondering, is this going to give me something that's greater than 0? Let's find out. -3 squared is positive 9. That's a positive 3. That's a -8. Hey, I just got one negative. That means I'm going to get a negative number. Is a negative number greater than 0? No. This is a fail. This section does not work. Why? Because a value in the section does not work. Let's try this section. Let's try positive 3. Everywhere I have an x, I'm going to put a 3. Three minus 5. Whoops. 3 minus 5. Question, is that going to be greater than 0? I don't know. Let's find out. 9 times 9 times negative 2. Look at there. One negative. That means this whole thing is going to be negative. Is that going to be greater than 0? Is a negative number greater than 0? Absolutely not. So this is a fail as well. All right, let's try one more, like positive 6. And notice I'm not choosing numbers that are interval markers, that are endpoint markers. I do not choose these numbers. I choose something in the section itself. So we're testing 6. 6 squared, 6 plus 6, 6 minus 5. Question, is that greater than 0? I don't know. Let's find out. 36 times 12 times 1. Is that going to be greater than 0? Absolutely. That's a big old positive number. Positive, positive, positive. Give me a positive number. Is definitely greater than 0. That's a good section also. So this is a good section, this whole thing, all the way to infinity. And this is a good section, all the way to negative infinity. Important question. What ending markers do I put here? Brackets or parentheses? This guy tells me, since it doesn't have an equal to sign, that I use parentheses. If this had a equal to sign, I'd use brackets. It doesn't, I use parentheses. So there, ladies and gentlemen, are my 2 interval solutions. But notice I'm to express my answer in interval notation. In interval notation, it's from negative infinity all the way to negative 6, together with, that means union, right? Again, parentheses, 5, all the way to infinity. So this is what Hawks will be expecting when it says put in interval notation. So again, the 2 steps are find your important ending points or critical points on the number line by setting each factor equal to 0 and solving. Then test each section, each interval, by testing a representative point. If something works, that's in the solution set. If something doesn't work, that's not in the solution set. All right, good luck to you. We got a test coming up in a couple of weeks, so keep that in mind as you gather your notes and stay up with the assignments. Good luck to you.